Hi, welcome to my presentation that I gave at the Lloyds Register Foundation's side event at the United Nations Ocean Conference in Nice in France yesterday. As I'm recording this, that's June the 10th. Really nice trip out there, very quick, very short, unfortunately for me. In a way, I didn't get a chance to get out on the beach, but really great events, really interesting, really stimulating, made some brilliant connections. And this video here is a chance for you to see what I was talking about and put a little bit more flesh on the bones on the ideas I've sprinkled across LinkedIn over the last few weeks, maybe even years. So I'm talking really here about it's the context of safer oceans and the need for engineering policy. So safer oceans is the kind of the intersecting point between the Oceans Conference and Lloyd's Register's Foundation's interests around safer engineering. And so I'm talking about engineering policy on that. And this helps to explain a little bit more about what's distinctive about engineering policy and kind of why it matters and how to bring engineering into government through, I guess, an explicit intentional process of using engineering policy. So this is really kind of for anybody who might just have a general interest in thinking, well, could engineering be for me? It's about sort of trying to blind spots in officials' minds in particular, and maybe even in engineers' minds as well. So let's move on. So when I was in the room, I kind of did the usual thing. I'm a social scientist. I'm not an engineer. And as a social scientist and an academic social scientist, I'm a kind of independent, critical friend of engineering, right? That's how I want to see it. So I have a very strong interest in it. I really kind of like engineering as a capacity, particularly the kind of physical engineering side of things, mechanical, electrical, chemical, civil, those types of engineering ones are really interested. But I'm also a kind of critical friend. So being an academic, being a social scientist, I can take that step back and just think a little bit more around, what do we have here when we have engineering? How is it interacting with society? What kind of effects are we seeing of this kind of engineering? Anyway, so the point being, as a social scientist, one of the things that social scientists do, right, is we collect data, we try and interview people, get information from people. And so what I did was I asked people in the room, anyone here who works in or around or for government policy, right? So the idea is that you think about, well, I work in government, I work in public sector, I work in maybe a lobbying organisation that works very closely in government, or an NGO that does that kind of work. Okay, so then I asked if you do that, raise your hand. And so I got a sense in the room. My guess at the time would be around 35 of them in a room of about 50, about 70%. I think in the end it was probably around about a third, maybe half, something like that. So if there was about 50 people in the room, it was about 20, let's say, who worked in policy, maybe 15. That put their hands up in answer to this question. And then the idea is that you keep your hand raised and you get the blood draining from your hand. It's like, don't know if I can cope, but it was a bit of exercise for them. But the idea is you keep your hand raised if you also work in engine, as it put there. Let me just drop myself down in as an engineer. And so over here, that's right, it's all mirrored, isn't it? So if you're an engineer, as well. So it's the idea of the degree to which engineers become policy or are in policy type roles at all. And my guess was that there would be maybe one, maybe two. In fact, there were three. Okay, so we got a little kind of super lucky in a sense, and in a sense that's not super duper surprising. I mean, I knew it would be small. I suppose the degree to which the name of the event, which kind of headlined engineering, right, was going to filter in out of those 35,000 people at the Ocean Conference, those for whom engineering is a sort of positive trigger, right? So we got more the kind of biased sample from this kind of broad community of people in the conference overall. So, but it made my general point that I don't know, a few percentage of people operate as engineers in government. It's a minority thing. It doesn't happen in a structured way, and this is within Oceans Conference and the sort of where engineering is pretty central to society's interaction with the ocean, right? Without engineering, you're not interacting with the ocean. In some senses, the ocean is I wouldn't say safe, so to speak, from human effects, because of course land-based sort of operations like off-running from agriculture and waste tipping into the ocean from land could affect the ocean. But the point is that, without the shipping, without all the various trawling and fishing type of activities that engineering essentially enables to happen, the sea would be safe. So the point being, it's like, even in this super engineering oriented space, there are very few engineers who work in policy. Now, I didn't do a poll about how many. I'm going to bring myself up here because I feel like I'm drowning a little bit. But the point is that I didn't ask actually how many engineers were in the room at the time. I could have done that, but I didn't. I only had 15 minutes to do this. So I'm giving myself a little bit longer, a bit more relaxed on this one here. So what they kind of all pointed to really is the main point I want to make, and this kind of touches on the paper that I posted, a preprint, Centre Research Policy, I'm calling the paradox of invisible engineering in government and policy, right? So let's just try and explore that paradox. What does it mean? Okay, so I think the way to, the point being, if something is invisible, how do you know that you're not seeing it, right? This is the kind of foundational empirical question here, or epistemological question even. How do we know that engineering is not there? Well, let's just sort of think about it in comparison to two very complementary, similar type sectors in this kind of space. So science on the one hand, obviously science, engineering often go hand in hand, and health sector. Health sector is very similar. There's lots of similarities, lots of structural similarities, and lots of intellectual similarities, I suppose, with engineering as well, right? And so across those three, we can ask certain questions about the nature of them and their relationship and their importance to society and, therefore to kind of government and policy. So would we say that these sectors are a key capacity for a nation to develop safely, right? So yes, you'd say that for health. I think that's fairly uncontentious. Science, I'm sure, absolutely, almost nobody would disagree. And engineering, absolutely, it's hard to sort of argue against that. It's sort of self-evident to some extent, okay? Now, the workforce size is another way of just kind of estimating the kind of importance of engineering to society. So we can represent that. Let's say this blob, this circle represents the size of the healthcare workforce. Let's say in the UK, it could be anywhere to some extent, and then we can see the relationship of science and engineering to the size of the social care of the health workforce. Now, I mean, I probably, to be honest with you, underestimate. That's probably a little bit bigger than that, but it doesn't really matter. The point being, it is quite small. The engineering one is, depending where you cut the cake, is roughly the same size, maybe slightly bigger than the health workforce, right? So, the point being, these are two really important sectors of our society. The kind of clusters of detailed experience, knowledge, and capacity to do things. On the one hand, to our bodies. On the other hand, to the body concrete of the country, right? So then we can ask, and this is where what I might need to do is just move myself out of the way here, because I think I almost can see that I'm going to get myself into trouble if I stay down in that corner. We can then ask a series of other questions to see, well, how well do they manifest in policy type spaces, right? So is there an explicit ministerial post with the name associated that we see here, health and science and engineering? Is there a policy in place that sort of is basically this policy or that policy, right? Is it the focus of academic, social and political scientists, which is another kind of indicator of the degree to which this exists as a sort of practice, as a sort of explicit practice within government? So we can get our little check boxes out here and just sort of see, well, is there an explicit ministerial post for health and science? Yes, there is. I think pretty much every country, I haven't done the maths done the counts on this, so to speak, but I'm fairly sure every country has a health minister and a department of health of some sort. Many, not all countries have a minister of science all the time, but many do. It's fairly common, but there's basically no minister or ministry of engineering anywhere in the world ever, as far as I can tell. I think it has never been a thing. Is there a policy in place? As most countries. I think all countries have a health policy. Most or many countries have a science policy, but you will never find an engineering policy, right? In any country, and that's partly because, of course, they don't have an engineering minister. So if you don't have an engineering minister, you're not going to have an engineering policy, right? As simple as that. Okay. Is it the focus of academic and social political scientists? Yes, there's a health policy journal, there's a science public policy journal. There's journals out there dedicated to the policy of these areas. Is there one on engineering policy? No, maybe I should say not yet in brackets, but no, there isn't. And again, these are all a kind of corollary of each other. And so what we're seeing, in essence, is that engineering being kind of like fading into the background, being removed from the visual landscape of policy making, and this is kind of one of the fundamental points, the starting points of engineering policy as a kind of logic. Now I found myself in line with the heading on this bit, so I'm going to bump myself back down here. So in order to sort of get to grips with this, particularly if you're not in engineering, right, it's really worthwhile going, well, what is engineering? Why does it matter that we talk about it explicitly in policy? And I'll tell you a little kind of story actually on the side of this event. There was another event going on in the next conference room. I think it was the Economist Impact or something like that. That's what they have in their lanyards anyway. And I was talking to this lady in the sort of foyer area where we're all sharing the little tiny croissant and coffee and so forth. And she was going, "What's this? What's you about?" I'm saying, "I'm talking about engineering." And she goes, "Well, what do you mean by that?" And I have to remind myself, I've been sort of thinking about this stuff for 2 or 3 years, maybe 4 or 5 altogether. And for those of us in this sector, well, engineering, we know what it is. Of course, it is, know it in detail. But for everybody outside, it's amazing how much of a kind of black box engineering is, and sort of, what do you mean? And I think it's really important to sort of unpack what that black box is for people, so that they can start to see the merits of thinking about it in a certain way. And she went away kind of like, I guess, enlightened, and hopefully, as you will be, by the end of this talk. So what is it and what isn't it? I asked the audience in there, what's a 2-word, there's a kind of classic 2-word definition, at least used in policy spaces, maybe not more generally, but at least used in policy spaces to describe engineering, right? So I don't know if you can think what that 2-word definition is. I mean, in the room they're shouting "making stuff," which is actually a pretty good one. I'd run with that, to be perfectly honest with you. But no, typically engineering is called applied science, right? I mean, you'll see the definition in the dictionary where it says applied science, that sort of thing, right, in there. And I'm going to just make this super nice, strong claim that engineering is not applied science. Okay, I mean, I'll tell you what is applied science. Science is applied science, okay? So engineers apply science, absolutely, just in exactly the same way that scientists apply engineering, right? So, there's nothing particularly special about that. The interesting point I was thinking about when I was writing this presentation was that, I suspect that scientists more often apply engineering in their work than do engineers apply science. That's my kind of general guess, partly because engineering comprises so many broader things than the specific process of designing maybe a new type of engine or something, which definitely requires a lot of scientific knowledge around thermodynamics and pressure and all the rest of it. But the point is that engineering is everywhere within science as well. So there's a sort of sense in which it's foundational to science in perhaps more ways than science is foundational to engineering, right? And I think the kind of the broad history of engineering demonstrates that relationship, which is another sort of like kind of crazy question mark about why we don't have engineering much more front and center in policy than science, right? But the other thing to remember is that engineering is much more than technology or innovation, as I was just saying, right? So it goes beyond the idea of designing a technology and adapting it and so forth, or creating novel versions and variations and techniques and so forth that we see in innovation. You've got a much wider set of practices that go from all the material extraction in mining and that kind of thing. That's not, the technologies are there, but it's kind of the whole engineering process around extraction of raw materials, processing of them, logistics, all the management of technologies, all the decommissioning of them, recycling, repurposing, all that kind of stuff, all parts of engineering, right? Much broader than purely the idea of technology and innovation, which are two terms that you see, commonly sort of held up as kind of key things to do in policy making. Why does it matter, right? Why does any of this matter? I mean, we've got technology policy, we've got innovation policy, Do we need to sort of talk about engineering, right? So I've written about this in a couple of papers, but I think there's a couple of points I wanted to drive home in the presentation. First is that engineering is often effectively privatized. I mean, many countries, like the UK, for example, large majority, I don't know quite what proportion, but I'm going to try and estimate that if we get the survey that I want to do funded. A large proportion of engineers are part of an essentially privatized sector, right? They're mostly working in private sector organizations. So you might have, maybe in the UK, let's say we have 5% of engineers working in public sector roles, like in the Environment Agency, maybe parts of National Rail, and so forth, maybe in the MOD, and then the rest of them are in private sector organisations in some form, right? Many of them transnational engineering organisations. Now, I'm not saying that's good or bad thing. I'm just saying there's that. Okay, that's the first thing. So, in some senses, one might, going back to that health policy analogy, engineering is a bit like the US healthcare system, right? And well, we all know how good that is in many respects for many people. So, just bear that in mind, right? So these are sort of two sectors. The American style health sector is largely privatized, and the engineering is largely privatized, right? So it's worthwhile bearing that in mind. The other thing that I think then intersects with that also makes it potentially sort of maybe exponentially problematic, if I'm being my critical friend for engineering, is that engineering is largely self-governed. And what I mean by that is that there isn't a kind of public governance around it, right? As we've established, there is no minister for engineering, there is no engineering policy, there are no spaces where citizenry, where democratic processes can interact with the shaping of the kind of engineering that we have in a nation, right? So the idea that it's, say, in the UK, almost entirely privatised, it wasn't a choice. It was a consequence of a series of other choices that didn't think about necessarily what would happen if you just mostly effectively privatised the engineering sector in a country, especially when the governance of that sector is basically done by the private sector. So it's the private sector governing itself by and large, because the way that it mostly works is through, on the one hand, things like engineering degrees, which set the kind of content, and those degrees are obviously set at universities, which are public, but they're set through kind of a chartering process and the standards. I can't remember the name. Sorry, Engineering Council. We'll get on top of this one day. But the kind of the ways in which accreditation, that's the word, that the Engineering Council gives to university degrees is partly done through the collective membership of engineering, which itself is from the private sector, and also engineering, university faculties engaging with the engineering sector, which is largely privatized, to make their degrees useful for graduates to go into the jobs that are in the private sector, right? So you can sort of see how there's this kind of private sector sort of whirl going on there. And so when it's all entirely privatized, I think that creates a certain kind of problem. In ways which, it's a bit like I said, having this American healthcare system, but without the Department for Health, right? So without any kind of public recourse to saying whether or not this is the governance that we want. So I think that's a kind of, it's a fairly provocative point maybe, but it opens up a lot of interesting questions, and these are the questions at the heart of engineering policy. And I'm not saying, right, don't get me wrong, I'm not saying that we definitely need an engineering minister. I'm not saying that the current modes of governance are themselves necessarily problematic, but they are potentially high risk, I would say, and that there is potentially no reason for them to be in exactly the form that they are, other than that's how they've always been, I suspect. and that there may be evolutions in the governance structures of these organisations, like the Institute for Civil Engineering, Mechanical Engineering, Engineering Council, that can enable a structure that is suitable for engineering. Doesn't have to be the same as health, but health provides us with a model to bounce ideas off, right? To ensure that risks that are potentially built into the system are mitigated in some way, right? So it's not going to, in the same way that you get major problems in the healthcare sector, just in the same way you get in engineering. So there's no necessarily perfect system, and that's not what we're aiming for here. But we are aiming to at least, open up modes of accountability and engagement with engineering, which may itself provide a way of boosting the kind of, certainly in the UK, it differs in different countries, boosting the status of engineers in the UK, or boosting the kind of profile in some sense. So all of these things interact, right? So I think there are kind of opportunities to be had in this space. Anyway, I've gone a little bit longer than I meant to on that point, but I just wanted to make sure I wasn't setting too many hairs running about this, but I just wanted to show how it opens up these kind of debates when we think about engineering policy. This is, it's just an example in a sense. Right. So, I'll just move out of the way here. So how do we turn these ideas into action? This was the theme of the session, was turning ideas into action. I put this sort of 5 stages of grief here. It's probably, that's had to the time. It seems like a good idea when I was designing the slides, but I'm going to leave them on there anyway. I mean, I didn't have to. But the idea being is that, if you're new to these ideas about the role of engineering and engineering policy, and actually, even if you're in the engineering policy space already, maybe you're a policy worker in, the Institute of Mechanical Engineering or what have you, right? Then the idea that by bringing in engineering policy, it changes your world view. That's and that you have to let go of your current worldview and kind of go, maybe it needs to be different, and you need to accept that difference in order to get to the better world that you're currently already trying to work towards. That's kind of the goal here. Right? I'm not trying to upset the boat just unnecessarily, but to try and get to this goal of engineering that really delivers for society in a deep and integrated and effective way. And I think that's kind of what I think almost the entire community is about. But it's trying to operate with a set of tools that don't allow it to get there. That's kind of my diagnosis, an engineering policy diagnosis of, at least in the UK. I can't talk for any other countries because the data, the analysis hasn't been done, and that's kind of the whole reason why I am trying to build up this program of engineering policy, maybe consolidated into what I'd call an institute, a kind of global institute, ideally, of engineering policy and ethics, in order to do this analysis, do comparative work across different countries, get the data all kind of set out so that we can sort of see how different arrangements are operating in different countries, what seems to work better in different areas for the governance of engineering and for the kind of outcomes that we're interested in, right? So this is the kind of the whole space that engineering policy is operating in. So anyway, back to my what do we have to do, I think, to move on the debate in this area. I'd say, if you're a policy official, or you're working with policy, and you haven't currently been using technology, you've been using innovation, I'd say start using the word engineering in your discussions with people. Where are the engineers? Where is the engineering? Can we talk about the engineering of this? Because I think it's important. We may be missing a trick here. So that's the kind of the simple thing that you can do if you realise the value of this whole space as an area of policy impact that you perhaps previously not leveraged in those conversations. Of course, the next thing really is to also, maybe simultaneously, is to understand and equip yourself and therefore others with the benefits of engineering can bring to organisations. I'm going to move myself out of the way because I can anticipate that I'm going to be covering up some of the next information. So when we're looking at the benefits, we're thinking about life cycle analysis, systems analysis, as the Royal Academy of Engineering, Government Science and Engineering in the UK promote systems thinking quite strongly, but I think there's a range. Life cycle can be understood as a kind of systems thinking, to be fair, but I think it's not identical with systems thinking because it provides lots of other kinds of ways of looking at the world. But one can see those two things as the same. But logistics and delivery is obviously, logistics in particular, I think tends to get forgotten in policy. the actual making of things happen in places and at the right time with the right amount. This is the core to a lot of engineering skills in this. And delivery, of course, is often what's core associated with policy, with engineering in policy. So delivery of high-speed rail, delivery of new energy systems and so forth, right? Yeah. But there's also things like material options, right? When you're designing, so low carbon concrete, the use of cross-laminated timber for construction, other kinds of materials for different types of computing or power or whatever it is, right? There's all kinds of possibilities when you bring in materials options in. And obviously, this is a really great intersection with science, particularly materials science here, where those science and engineering can really work effectively to open up new policy options that are rooted in new materials. I think materials is a really super interesting area. Design options, I think, is, for me, I'm not going to go into this too much detail, but design options are also a really important thing. Obviously, we have the idea of policy design, but actually when you bring it down to engineering design, I think one can see that as a whole new class of policy option, a whole new policy tool, right? A design, the engineering design options and what they give you. And of course, certainly within the Lloyds Register space, safety orientation, which varies massively across different engineering sectors in terms of the way in which they think about safety. But also safety itself requires lots of, brings with it lots of different ideas, and it's also worth bearing those in mind, because when you engage with engineers, because that's the next stage, obviously it's talking about them, you want to actually bring engineers into the conversations with you. And this is about creating spaces for what I call critical dialogue with engineers to explore policy issues. And this is, the dialogue issues. So there's things like the Royal Academy of Engineering's Policy Fellowship, which is, super worthwhile doing. Definitely worthwhile doing if you think your area doesn't have anything to do with policy. Definitely go and check that out. But have a look at that. But the bringing in engineers, different kinds of engineers, and having a critical dialogue with engineers. So it's, I think a couple of things that we've learned. So with my colleague Laurent Lyotet, who's over at MIT at the moment, a PhD that I supervised, really great guy. We found some things, and I found some things when I did studies with engineers in UK ministries. And we can see a little bit that engineers can be maybe a bit what we might call overconfident in policy, or potentially not challenged sufficiently to generate designs good for society. There's an indication of this, right? I mean, the problem is that data is not really sufficiently widespread for me to make these claims more generally. And that's part of the issue with this space, right, with engineering, because engineering policy hasn't existed until I've started talking about it in a way. I mean, that's not quite true, but it's true enough. That there isn't the data to help you think about what kind of engineering policy we have and whether we want it like that, and so forth and so forth. So a lot of what I'm saying, right, is just based on little snippets of data, little snippets of insight in different areas, and I'm kind of extrapolating probably a little bit outside the sample than I should, but this is to sort of kind of provoke the discussion and provoke the interaction in order for us to say, hey, we need to get more data and better data on this fundamentally. The other thing I think that's really interesting, and this was basically, it was a point that Chris Wise over at Useful Simple Trust made at a recent Royal Society event hosted at the Royal Society by the Foundation for Science and Technology, really great organisation. And Chris Wise kind of made the point that you see a lot of over-designing for safety. And I think, so the idea that, the safety standards that engineers are bringing into, say forms of policy delivery, it can create problems that kind of outweigh the benefits of the implementation of the policy, right? I think it's just kind of, it's a bit like in health again, right? With health, we have NICE to help balance off the risks and the benefits of certain things. And I think, so these are examples of why you need to be kind of critical, not just accept face value what the engineers will say to you, but kind of ask detailed questions to unpack and unpick. And that's part of that kind of critical dialogue. Anyway, final point really is about employing engineers, bringing them into the public sector, bringing them into public policy. I think that's kind of one of the biggest things, certainly say for the UK, it needs to do a lot more public engineering. We've had municipal engineering in the past. I think other countries have quite a lot of municipal engineers at local level in particular. I think France, maybe Germany has them. Again, data is a bit sparse. It's probably out there. There are probably people who've studied engineers at that kind of level. I know one or two papers in the UK on this. But the kind of the point is that the next stage really is to employ engineers into policy roles, like was done when I joined the Department of Energy and Climate Change decade ago, more than a decade ago. But it needs to be done in a kind of planned way, and I don't mean just sort of make sure you've got the timeline set for the advert to go out. But what I mean by that is that, so what we've seen, and this is a little more kind of concrete in a sense, maybe the previous inferences that I made, is that what we know very strongly, this is a really key part of Laurent's work, is that engineers coming into policy, they need to learn a new policy language. And there's a whole kind of, and Laurent's just written a really nice paper on that with myself and another colleague, Neil, at the Energy Institute here at UCL. And it requires them kind of moving away from what we might call the engineering triangle, the kind of cost, speed, quality kind of parameters for good design. And there's also a tendency for engineers to need to be close to stuff, otherwise they feel like I'm not really doing engineering, right? And that's absolutely fair enough. And I actually think this is a super important point, particularly when you get into ocean safety side of things, because the physical objects, the ships, the ports, the materials within the ports, these are all the kind of manifestation of the policy as is. And until the engineer gets in there and sees how things are operating, sees what's going on, applies that engineering knowledge to what they expect to happen versus what they see happening, then the value of the engineer in policy is diminished, right? So there's a need, I suspect, to bring engineers out of the offices, which are often based in capital cities, out to the outer edges of your country, if you're, to the port areas, and facilitating those kind of interactions. And I mean, I think that's generally true of any kind of policy making, is to get out of the abstract conceptual spaces of offices and into the kind of lives of actual people. Just because it embodies a bit more the facility to see the different angles, see the different complexities that emerge. And obviously, social research plays a key role in enabling lots of different kinds of settings to be expressed in policy. But I think, when you bring in an engineering angle on that, you open up a new thing. And I suppose the flip side of that is by not doing so, you can alienate engineers and they may leave the work and you get high turnover. And of course, then the whole value of investing in engineers in policy gets lost, because you're ending up continually retraining, people are starting fresh, and then it's like, why have we got these engineers here? They're not really helping us, right? And just causing problems, they're just running off, creating kind of policy, because they're engineers, they want to solve stuff, so they're cracking on, they're doers, and it can create potential kinds of problems, I suspect. So I think the point being, either way, is that, it's definitely great to bring engineers into policy, but it's not a simple task to do so. It's a non-trivial kind of task. And one of my kind of to-do lists is to create an online module that engineers can follow to prepare themselves for policy making, and for policy officials and maybe social scientists as well, I think, to understand and engage with engineering in their work, because by doing so, it helps bring engineering back out into the light. And it will make engineering better, it'll make social sciences better, it'll make policy better, I think, by that kind of virtuous sort of circle of interaction. So, I'm going to get out of the way again. So, hopefully you've enjoyed that. A little longer than 15 minutes that I got, but you've got a little bit more content than I was able to give during the session. Please do get in touch. Here's the paper on engineering policy, and it's open access. You should be able to read it. Let me know if you can't. And I'd love to hear from you if you want to get engaged, if you want to be part of the emerging global institute on engineering policy and ethics. That's, or whatever we're going to call it. I don't know. That's the working title at the moment. Get that off the ground. You want to get engaged, particularly obviously if you're in the institutions or anything like that, super engaged. Would love to be super engaged with all the policy people in those spaces. So thanks for watching that, and hope you found it kind of eye-opening, interesting, useful as well. So cheers.